We'll start immediately or give it like 30 seconds after we go live?
No, we can start.
Okay,
We have
great.
started.
Sure. Okay, great. Welcome everyone. So we are going to talk about improving Kubernetes developer workflow with Kind and Scaffold. Thanks for inviting me, the Pune developer community, and good to see the Tech Carnival. Very interesting talks on various interesting topics. So, very brief about me. My name is Vishal. I'm CTO and founder at InfraCloud Technologies. We are a company exclusively focused on CNCF technologies, and we work in many open source projects and areas, and also do consulting for many enterprises in the cloud native space. We organize Kubernetes Pune meetup every month. Last few months we have been doing it, of course, virtually. So please join us and take advantage of the sessions on the Pune Kubernetes meetup. And I can be found in the usual places on Twitter, LinkedIn, and stuff. Cool. So let's start with the demo because what's better to start with the demo than to do with slides. So what I'm going to do here is quickly. I have this simple application which has a simple Helm chart that I'm using and a Docker file which has an Nginx deployed into it. And I'm going to deploy it into a cluster right here by creating a cluster on the fly. So I'm using Kind to create the cluster. So I'm creating cluster. What Kind is doing is it is using the Kubernetes version 1.18.2 and then preparing a single node cluster here. And it is bringing up that using Docker. So the way Kind works again is it uses Docker as a node, a Docker container as a node basically, and you can spin off like a single node cluster, multi-node cluster, whatever you want. And as you can see, it has already pulled up the image. It is running a few configurations and now starting the control plane. In our case, since we have a single node cluster, the control plane and worker plane is gonna be the same. But we'll look at other options later in the demo. All right. So as you can see, the cluster is already configured. And if I do find get clusters, you can see I have one cluster, which is Kind. And just to get the parts, I'm getting parts from all the namespaces. As you can see, most of the parts are running except for code DNS, which should be coming up in a second or so. So I have now my full-blown cluster in less than 30 seconds up and running on my own machine. And what I'm going to do is deploy to this cluster using Scaffold. So I'm going to run the Scaffold Run command in my Helm deployment, which is simply deploying a simple Nginx. Let's give it a minute here to see if the core DNS is also running. Great, it is running now. And I'm going to do Scaffold Run. So all it is doing is taking the current directory with all the code and the Helm chart and tagging it appropriately, and then deploying that into the cluster. In the case of Kind, it actually loads it in the cluster as well. So as you can see with the last line. And there we go. So we have our application deployed. So we can see the Scaffold Helm application is deployed. We can also see the pod running, the Scaffold Helm pod. And that's it. We are live into a cluster, in the matter of a few keystrokes. So what did I do there and why I'm doing this? So let's go back to the slides and look at a little bit of context. So if you look at any non-trivial application today, it is typically, has a few components. If you're using microservices, you're talking about a few services like warehouse service, product catalog service, shipping service. Maybe have a simple database, maybe have a caching, technology like Redis or something similar. Maybe there is a message queue and there's going to definitely be a front-end component to it, right? And so any application today is not a single component. It's typically a few components put together. Now, let's say as a developer, I want to introduce a new feature in my product catalog service. And I have this amazing idea to enable people to find the products that they need. And I want to implement that, right? So then I got a couple of options. So what I can do is I can take out the product catalog service code base and make changes only to that service, test only that service, and then mock out every other dependency. If it is calling a database or a message queue or a caching service, I can mock out those dependencies. And as long as I have a very clearly defined contract, I can be confident that my change is also going to work integrated with the rest of the components, pretty well. And once I'm happy with my local changes, with all the mocks and testing and everything done, I can send it a PR and then probably follow through integration testing and eventually deployment to production, right? But as we know, this is an ideal world, and we live in a pretty world which is probably in between, right? And we see typically the testing that we see in larger applications, in larger organizations, or larger code bases involves multiple levels and multiple ways of testing, right? So there is, of course, unit testing at the component level or individual service level. Then you have some component test boundary where you say, I'm going to check the external connections, the interfaces. Then there is integration testing. There is also other testing like external testing or end-to-end testing, and so many kinds of testing that we go through eventually before putting it into production, usable by the end users. So the reality is actually in between. Unit test, of course, is a great way to validate your code base and be confident that the change is going to work. But the coverage of unit test varies from organization to organization, application to application, and also different teams follow different standards. Same probably goes with the contract that we follow for a given service. That somewhere the contracts are very clearly defined, but there are some places the contracts are loosely defined, or you can't define very clearly. And then, of course, what happens is you try to find a middle path. What you try to do is you deploy the whole stack along with your change. So what you do is basically you take your change of product catalog service, but also deploy these other services to be really confident that your change is actually working as it should work, in a given scenario. So as Cindy is one of the persons on Medium and Twitter. She talks a lot about these things. You're basically building and testing microservices, but in a monolith style. So although everybody is trying to develop microservices, what we're actually doing is we are lumping together all these microservices and deploying into a cluster and see if it works together, right? Not ideal, of course, but this is what we do. Then there are also other challenges with Kubernetes now, coming in the picture as the main or kind of pretty commonplace deployment runtime. How do I simulate things like secrets or config maps or volume provisioning? Or how do I ensure that my code is, of course, in my code base, which is Golang or Java or Python or whatever, but there's also a lot of configuration in the Helm charts. For example, I might have some things which are templatized in the Helm chart, and values are getting actually rendered on the fly. I want to ensure I test out those as well before I push it out for integration test, right? And then there are dependencies on Helm charts and those kind of things. So there are also real challenges when you deploy to Kubernetes. So as a developer, what I want to do is I want to deploy a few services, maybe my service and a couple of other dependent services in an environment which is as close possible to Kubernetes as I can get. But at the same time, I don't want to lose my quick and fast feedback loop, right? I don't want to every time deploy to a cluster after I change and wait for 30 minutes for the deployment to go through and then test it, right? That's going to make me very, very slow. So what I want is I want a quick and dirty way where I can deploy something to a cluster, but at the same time get that ID kind of feeling where I can in real time change something and look at the effect of what is happening in the cluster, right? So if you look at it broadly, we are trying to achieve two goals. One is a cluster which is fast, lightweight, and can be spun off easily. And it is as close possible to a real-time environment, if not 100% as it is. And the second thing I want is a simple workflow where I can simply fire a few commands and get my change into a cluster up and running, and then I can reiterate in the same workflow as fast as I can. All right, so with that, let's look at some of the options that are there in the cluster and the workflow tooling and technologies as they have been evolving last few years. So of course, on the cluster side, Minikube is pretty popular. I have used it probably a couple of years ago. I haven't used it in the last probably 6 to 8 months. But what it essentially does is it basically spins up a virtual machine on your computer or wherever you're using it. And then it creates a single node cluster, which you can deploy against and test against, right? Minikube, of course, is growing in terms of feature set. So you can do quite a few things today that were not possible like 6 months ago or almost a year ago. So it is a good option in many use cases. The reason I personally don't like it is because, first of all, you only get to create only a single node cluster. You can't ever do a multi-node cluster. The second reason, I find it very heavy. So it needs a virtual machine of 4 GB or 6 GB or 8 GB RAM. and then inside that it creates cluster. It makes the whole boot up and tear down super slow and very complicated for me. There's another option called K3s. This is a project from Rancher Labs, created as a lightweight Kubernetes for running on the edge. But a lot of people found great use case for doing CI or development workflow. And there is an ancillary project called K3D, which enables you to manage K3s effectively. It's a great project. It's a single binary. It boots up really fast, like less than 30-40 seconds, and it's a great product for many use cases, including CI and also IoT. I haven't played around or dabbled with it a lot, so to speak. So I can't speak of any downsides, but it is one of the most popular projects when it comes to developer tooling or creating clusters for developer usage. Excuse me. A lot of people, what they also do is they create a large shared cluster for the developer team or development team. So let's say I have 150 plus developers in my organization, and I have approximately 10 or 12 teams, let's say 5, 7, 8 people in each team. What I do is I create a large cluster, and what I do is I assign one namespace to one team, so that one team can use that namespace and deploy within specific resource quota limits your applications, test them out, and do those kind of things, right? The other option, of course, is you can try to create one cluster per developer in cloud, but that's going to be super costly. So it is not the most desired approach, in many situations. And then there is Kind, which is what we're going to talk about today. So Kind stands for Kubernetes inside Docker. What it does is it basically treats a single container as a node, and within that node, it deploys other things which are components of Kubernetes or your worker parts. You can create multi-node clusters. So you can have, HA kind of situation where you want to create multiple control planes, or you can create multiple worker pools and those kind of things, right? And it is super lightweight and very fast. And we'll again look at it slightly later in the slides. So that's about the cluster options. And I'm not saying these are all the options that are there, but these are the ones that I have most usually seen and used myself as well. Now coming to the workflow side. So on the workflow side, what I really want is I want a single command kind of way where I can do the entire building of Docker image, pushing them to cluster, deploying through Helm, and make it ready for me to test, right? So there are again quite a few tools available here. One of them is Garden. Now Garden is a superb tool with great visualization. It does something called a stack graph. So based on your definitions, it determines this component depends on this component, and so on and so forth. And it only changes the components that require change when you change a certain line of code, right? So that's a very nice feature because you don't want to redeploy again the whole stack. Only deploy the things that technically get affected and not deploy the whole thing. One thing I personally didn't like about Garden was the heavy configuration. So at every module and submodule and the top level, you have to write very, very heavy configuration. And it almost intrudes into your application definition, which makes it a little difficult to manage and cleanly separate the application code base versus the configuration of your Garden. There's another tool called Tilt. Tilt is again a very simple and nice tool. It works with with your Docker files and Helm charts and kubectl or Kubernetes manifests, and it has a very nice, simple to follow JS kind of syntax, and it provides a very nice UI where you can actually see the logs and the updates of cluster services when you're deploying and stuff like that. I personally found a few plugins which I wanted to use kind of missing in Tilt. But nevertheless, it's a great tool. Also, and again, used by many teams, including Kind team, I think uses Tilt pretty heavily. There's another tool called Scaffold, which comes from Google, which is what we are going to talk about today, slightly more in detail later. But it's all CLI driven. There is no server component to it, and it provides a nice opinionated approach, which has a pipeline built of a few phases. So build, tag, deploy, and test phases. And in each of these phases, you have plugins available. For example, for build phase, you have Bazel, build packs, or JIB and Dockerfile, plugins. Again, for deploying, you have Customize, Helm, and kubectl, and those kind of things, right? And it does support many other important things. For example, instead of building image every time, what I want is I want my local changes to be pushed into cluster in real time, and not have to rebuild the image every time. It also supports port forwarding, so I can debug or I can connect to a remote service and run some other service locally and those kind of things. Other than these tools, again, there have been many tools that have tried to solve either the whole problem or part of the problem. For example, Azure had a tool called Draft, which was very similar to Tilt or Scaffold in terms of what it was trying to solve. But it had been active for a while. I don't see it too active in recent times, at least. Ksync is another tool which basically allows you to synchronize your local changes inside uh, to a container inside the cluster, so that you don't rebuild the image every time. You only rebuild the binary or the source code. Is copied from your machine as you change to a cluster inside the cluster. Sorry, the container inside the cluster. There's another tool again called GitCube from Hasura folks. Kind of not exactly more like a sync, but again more like a developer workflow where it makes it easy for you to spin off an entire manifest and charts instead of you knowing everything. Again, I haven't dived too much in detail in GitCube, but kind of tries to solve a similar problem. Telepresence is again very similar to how do you enable a presence of your code into a remote cluster, and it does a bunch of those things. So I'll take a quick minute break to see if there are any comments. Okay, what is the best approach to test microservices before deployment if that microservice is dependent on other microservices? Right. So I think that is what we are going to talk about here slightly. There are a couple of things that we did cover in terms of you can try to mock the other microservices, or if you have a very clearly defined contracts, you can use the API endpoints and almost simulate those API endpoints using Swagger or something similar, so that you don't have to actually run that service, but you run a simulation of the actual service. All right. So with that, what I want to do is I want to show a demo of how I use Scaffold and Kind to test my Fission development workflow. So just to give you an idea, the Fission, the demo that I'm going to do, I'm going to create a multi-node cluster. So I'm going to create a cluster with one control plane component and 3 worker node components. Secondly, Fission requires a few different images to be built. So I'll build all those 2, 3, 4 images and deploy into the cluster. And eventually I use Helm to deploy that into the cluster. So let's first walk through the Kind configuration and then eventually walk through the Scaffold configuration and then create those things to see how it works. So initially, when I had demoed in the beginning, I only used the Kind CLI to actually create a cluster. But if you have too many options and if you want to create a fairly complex cluster, you might want to use the YAML definition. So here, if you look at it, what I'm doing is I have a cluster Kind, and then I'm defining nodes. So on the control plane node, I'm defining a few additional things. For example, I want to also enable ingress, and I'm enabling a few port mappings. Secondly, I'm defining 2 worker nodes. On the worker nodes, I'm not doing anything specific in terms of configuration. So I'm going to basically create a 3-node cluster. Now, what I'm going to do is with this definition, I'm going to create a 3-node cluster. Let me actually delete the previous cluster so that I don't end up running out of resources on my machine. So it's deleting the previous cluster, which is named Kind, right? And now I'm going to create a new cluster with this new definition that I have. So I'm going to pass the config as a Kind YAML. I can also pass a name if I don't want the Kind name to be used, but let's just keep it Kind for now. Now, as you can see, it is trying to now spin up 3 nodes of the cluster. And Kubernetes version is 1.18.2, but I can choose any version from like 1.15, 16, 17, whatever. So this is one good thing about Kind is that if I want to test my application against multiple versions of Kubernetes, I can create cluster 1.16, test it out, tear it down. Then I can create 1.17, test it out, and tear it down. So that's again very useful to do if the cluster provisioning and destroying is pretty fast. As you can see, the cluster is getting created. Now it is joining the worker nodes. And just to show you parallelly, so what it's going to do is it is creating 3 containers, as you can see in the Docker PS. And one of the containers is master control plane, and then the other 2 are worker nodes, basically. And it has set up accordingly the port forwarding for those things that we configured in the configuration of the master node. All right, so my cluster is ready. And I'm going to do, again, just a quick validation that all the pods are running in my cluster. All right, so as you can see, core DNS, 2 copies, kubeproxy for 3 nodes, 3 copies. and then everything else kind of remains the same. I can also show you that it actually shows you 3 nodes. So there is one master node, and then there is 2 worker nodes, of course. The worker node is not yet ready. The second worker node, it is still coming up. In the meantime, what I'm going to do is I'm going to create a namespace for my Fission deployment. All right, so now all the 3 nodes are ready. Now we have cluster ready, again in less than kind of 60 seconds, I believe, a 3-node cluster. Now let's go and look at the scaffold config, what I'm doing with Fission. So for Fission, I'm using the scaffold config to build out 3 images. So in the build section, I specify the artifacts, and I say I want to build 3 images. The context for these 3 images is again different, and Docker files is again different. Secondly, I'm specifying a tag policy. So tag policy by default uses get commit as a tag for the image that it creates, but I can always use a different tag policy. So here I'm saying I want to use a templated tag policy, and the template should be that it should use the image name, which is what I'm specifying here, and it should pass a tag variable, which is what I'm going to pass through command line when I actually call the command. So it looks for tag environment variable, and if it finds it, it basically appends it to all the images that I'm creating here. That's the build section. Now, if you look at the deploy section, I'm using Helm, and I'm saying release name should be Fission. The chart is stored in the charts Fission all directory, and the values file is in the same directory with values.yaml. Then I'm setting a few values, which is namespace for this should be Fission, and the repository is basically Docker Hub. And then I'm setting a few other additional things. So there is slight difference between set values and set value templates, is that in the values, it simply hard codes the values, whatever you pass. Whereas in case of templates, it's going to replace this templated values with the actual values that we pass from the CLI. So there is slight difference here. And then I'm again setting up image, fetcher image, and image tag, and those kind of things. And I'm saying wait true so that the release actually goes through or doesn't go through. We'll wait for that to happen. And then a couple of other options. You can also pass additional options like timeout and stuff like that. But this is again what we have right now. So as you can see, when we fire this scaffold command using tag and the scaffold run command, what it is going to do is actually build these 3 images, push them to Docker Hub, and then actually kick off Helm deploy, which is going to pull those images and then use the chart that I have defined here to deploy all the components. So in case of Fission, I have about 7 or 8, odd small services. I also install Prometheus as part of the install. So we'll see all those. All right, so I'm going to kick off the scaffold command. So add use tag 205 before. Let's do now tag 206, scaffold run. So as you can see, it has understood the tags for the images. One other beautiful thing it does is it basically uses it checks whether anything has changed on the code base, and if it hasn't changed, can it reuse the images from the previous build? So again, it is going to save time in terms of rebuilding those images versus reusing whatever layers or images. And now it is trying to load those images into kind, as we can see here. And now it is installing Helm, so we should see that. So as you can see, it is also downloading the dependencies of the Helm chart. For example, it is looking at Helm repo, KDA repo, and Bitnami, and then actually downloading the Prometheus chart, which is one of the dependencies for this chart. I'm going to switch to namespace Fission and look at the pod that it is going to create. So as you can see, it is creating a bunch of pods. So I have builder manager component, the controller component, the executor component, the few Prometheus pods, then there's InfluxDB and a bunch of other components. And then it is deleting the outdated charts, which it doesn't need anymore. The release is still not listed, so that is still working. Yeah, many of the pods are running, still some are creating, a few are failing. So in this case, it is eventually going to fail the release. There is a knowing issue that I have with my chart, which is the logger pod doesn't run because of some issue in the logger not able to access a particular service. Yeah, as you can see, the logger service is crash loop back off. So this issue of logger again is only to do with kind. It actually works pretty well with GKE, but there is some issue with kind that I'm still trying to debug and fix. But you get the idea. Yep, everything else is running now except for the two logger pods, which are daemon sets, for collecting logs for functions from various nodes of the cluster. But it's gonna wait till the timeout window, which is about 5 minutes for Helm chart, and then it is gonna eventually, say the release is failed. We'll just wait for that for a minute. So although the release kind of technically fails from Helm's point of view, in terms of my functionality, it is still working fine. The logging functionality, of course, won't work, but almost everything else works fine. That again, as I said, is an issue with this logger that I need to fix in the Fission code repo. Yeah, it works otherwise pretty well for testing functions and stuff like that. So while this is coming up, let's go to the Scaffold config and quickly take a glance over what all Scaffold can do, right? So Scaffold, the basic metadata spec and the API definition, kind of looks like a basic ini manifest in the Kubernetes world. In the build section, you have multiple options. So you can define artifacts. You can define the context, for a specific repository or image that you're building. You can define sync options, and those sync can be either manual or it can be inferred. You can build a Docker image with again multiple arguments in terms of build arguments, network, whatnot. You can use Bazel. Bazel is a very popular build and deploy tooling. There is Jib, which is actually mean for Java, and it is Jib is again an open source project from Google. Canico actually can build your source code inside the cluster. We'll talk about that slightly later. Then there is build packs, which basically enables you to write applications without necessarily understanding and writing all the Docker files. And there is custom build commands. Now, if you go to tag policy, again, bunch of options there. And then if you go to a registry, you can push to a Google Cloud build or actually build inside Google Cloud and stuff like that. And then on the test side, you can define what test image to use, where can you find the test, and those kind of things. And then the deploy section talks about Helm and other options basically. So as I said again, if you go to Scaffold pipeline stages, you'll find kind of the whole workflow, how the Scaffold works, how does it do file syncing, where does artifacts get built and what happens. And it's a pretty pluggable system. So you can plug in other things as well. And of course, it being open source, you can also hack it around and develop new plugins or whatever. All right. So as we can see, the Fission kind of Helm thing did actually fail. But if you can see from the pods, almost everything is running except for the logger pod. And I can actually use this cluster as it is. And as I make more changes to my Fission code base, I can simply run Scaffold Run, and it is going to, again, deploy my local changes into the client cluster, and I can test it out again, right? So that was a quick overview of how I can use kind and Scaffold with Scaffold definitions to deploy my cluster. Now, one thing I'm generally noticing in terms of how the developer workflow thing is changing, I see something evolving as a trend, which is more and more of in cluster development, and I kind of feel that is where we are headed in terms of future direction. Of course, I don't know for sure. Things might change as we go along, but it's interesting to see how this will evolve. So, if I were to give you a few examples, in cluster build is again pretty promising and interesting technology. So instead of trying to build Docker images locally or anything, for that sake, building locally, what Canico allows you to do is simply upload your code base or the context of your code into a bucket or someplace where Canico can access it, and Canico then actually builds that inside the cluster, all in the user namespace without requiring the Docker engine. Now, this is really helpful because what is going to happen is, if you're talking about a development team of 20, 30, 40 people, all of their dependencies are very similar, and everybody will try to deploy and download all those dependencies locally on their own machines. But once you start doing it inside the cluster, what is going to happen is all the share layers, all the shared layers can actually be cached inside the cluster. So you don't need to download all the layers again and again, and that is going to optimize a lot of things by caching in the cluster. Secondly, I don't need a powerful machine anymore, like 32 gigs RAM or whatever. I can use my cluster to actually build my code base inside the cluster and then on there deploy itself, right? This is again going to make the whole workflow a lot more simpler, easier from developers' point of view. Second thing I'm seeing as a trend is in-browser development. I don't know if you have noticed the announcement by GitHub in the GitHub Satellite conference a couple of days ago, but they basically launched GitHub Code Spaces, which is like VS Code kind of a ID inside the browser. It allows you to do autocomplete. It allows you to do almost everything that you can do on your local machine. Then there have been platforms like REPL.it around for a while, which allow you to run simple 1, 2, 3 file kind of code snippets or actually code files into the browser itself, and it allows you to build, run, deploy everything in the browser. Then there is Gitpod. I have been myself dabbling with Gitpod for quite a while. It basically allows you to run your code inside the browser, and there is a pod running in a Kubernetes cluster that they host behind the scenes, which is actually doing all the heavy lifting of building and deploying and those kind of things. So let's take a quick walkthrough of these three tools. So CodeSpaces, of course, right now is in public beta, so not everybody has access to it, but it looks very promising based on the videos that they're showing on the website and the demo that they gave in the satellite conference. You can do many things all in the browser itself, and I know that this is based on VS Code because they have been developing VS Code in a way that is also extensible and pluggable in browser as well. Then there's REPL.it, which is again a simple kind of code base. And I don't know why this is not loading. Let me refresh it once more. Yeah. So again, I have a simple Golang file. I can go build here and actually run it here itself, right? Again, I'm not saying this is great for full-blown projects, where you need to have multiple microservices, multiple folder structures. But again, this is just the beginning in that direction, right? Similarly, if you look at Gitpod, Gitpod is actually a little more, more advanced than REPL.it. And again, we'll have to wait for code spaces to get launched to see how does it compare as compared to Gitpod. So as you can look at Gitpod, it is basically provisioning a container for me. So it is basically initializing the workspace, and it has a unique URL that is assigned to me. And once the container is spinned up in the cluster, it is actually going to show me the running, so I can see the entire my code structure here. I can actually go and make changes to my code right from here and stuff like that. And once I do that, again, this is again based on the VS Code as a core platform. And the type, I don't remember the name of the company, but this company has built it on top of VS Code. So you get a similar console in terms of plugins and code branching and stuff. You also get a terminal right here, so you can actually fire commands right from here. And this can be tied to any Kubernetes cluster, or you can use kind within this VM itself, so to speak. So yeah, that's about Gitpod. So if I generally look at these two things, I think in-cluster build and then in-browser development. And I think we have been anyways doing the deploy and testing in the cluster itself for a while now, whether it is a virtual machine or whether it is a Kubernetes cluster or any other cluster like ECS or whatever else. And if we couple that with some advanced techniques that have been evolving over the last few years, for example, launching dark, right? You launch a feature which is not visible to the end user. Maybe it is only visible to the testing team, but it is actually live in the production, code base or production environment. But you're just, making it dark. Or you're launching that feature only for a subset of users, which are more like sub-users, super users, or very advanced confident users, right? And of course, tracing, right? So there are many techniques which have been evolving over the last few years, where people are actually dabbling with the idea that, hey, why do I need to actually go through this, dev, QA, staging, test, and then actually, production lifecycle? What if I launch it in a way where it is not affecting my existing production application, but I can actually test it in almost, kind of production like environment, right? Because you might have again seen sometimes some issues are only reproducible in production. They're not reproducible in dev or QA unless you can very deterministically say this is what the problem is in the production. And again, other techniques like chaos testing or feature flagging basically have been there for a while, but they are now coming off uh, you know to a maturity where I can actually do all these kind of things in production or production like environments, where you get to push your code to almost like a real kind of environment and then test it. So I think the final goal is basically to make it easy for developers to get from code to production as soon as you can in a environment and uh, which is very similar to production basically. So before I kind of close my talk in general, I want to do two shout outs. So one shout out is to the Cindy. This person is on Twitter and Medium. Her articles are amazing, and some of these snippets for example, about this image and other ideas that I borrowed from articles written by Cindy. And secondly, she also reviews a lot of research papers, in the field of computer science, and posts, like important snippets of that on Twitter, which I find really useful and very interesting in terms of learning. Secondly, we do support two open source projects. One is BotCube and one is Fission. So BotCube is a bot for your Kubernetes cluster. It does support Slack, Mattermost, and Microsoft Teams as of today. We are also adding support for Discord. So you can run all the Kubernetes or kubectl commands from within your Slack or any of the chat tools, and fire them to Kubernetes cluster and get the results right in the chat window. The better part again of that is you can actually have different teams. Like dev team only get to only read access on the cluster, whereas you can have another channel for DevOps team or operations teams, which can actually modify a cluster right from within Slack. So you can enable a very nice and integrated approach in the chat tool of your choice to talk to your Kubernetes cluster. So that's one open source project that we have been developing for almost last 18 months now. The other project is Fission. It's a serverless project on top of Kubernetes. And we have been contributing to this project for a while now. We have also implemented for a couple of customers. And it's all again open source. Feel free to hack around. If you have questions, join the Slack and ask there, and I'll be happy to answer those questions or help you with development workflow. So thanks for listening to me patiently. We are done, of course, a little bit ahead of time, but I'll go to the questions on the live and stay around for maybe 5-7 more minutes and answer if any questions are there. All right, so I'm going to go through questions one by one. What is the best place to do patches on top of things? Images, think of someone wants to customize. So Sunil has asked this question. So Sunil, I think the best way to do that is probably use the real-time sync possible in Scaffold. So instead of building and deploying the whole image again, you can say only sync a few specific files from my local machine to the cluster, and that should be possible. Nachiket says, what is it you would underneath to create nodes? So I'm assuming that question is for Kind. So Kind actually uses Docker container to create the node. So a container on your machine is acting like a node, and it does a few things under the hood, to enable that. Suyog probably has responded to Gaurav, I believe. All right, Suyog has answered a few questions as well. If you have any more questions, I'm around probably for at least 3-4 more minutes and happy to answer those. Yeah, so I can post the slide deck on the YouTube video, or probably here in the comments. Okay, I don't see any more questions, but if you have any questions, please post on the YouTube or Facebook. Go live. I will try to answer them. After I, kind of exit this live stream as well for next like 10 minutes or so. But okay, there's one more question. How can I customize the arguments to a Kubernetes system pod such as Kube API server in kind? That's a good question, Mohan. I believe. Let me quickly check. I don't know if Kind does support that. It has a few options around like networking, in terms of giving a service subnet or a pod subnet, or providing what kind of CNL plugin you want to use. But I don't know if you can actually pass arguments to Kind itself. Let me see if there is an issue filed for that on Kind. Maybe it's a feature which is not there yet. Uh, Yeah, so to answer your question, Mohan, I don't know for sure if there are any arguments you can pass to the Kind in terms of like arguments to API server, for example. But I'll have to check the GitHub for any issues. Abhishek has a question about any plans of covering mentioned tools in detail. Potentially, yes, and maybe upcoming PDC meetups we can try to do that. Can Kubernetes? So Gaurav has a question: can Kubernetes detect the updates in Docker images so respective pods will get restart? Gaurav, yes, absolutely. So when we push out using Helm and update a new tag, you basically create a new tag and then push that tag. So definitely the pods get restarted and everything actually does happen like almost seamlessly. Um, right. Let it start. Gaurav, yes, absolutely. So when we push out using Helm, okay. Thank you, everyone. Thanks for making it to this session. I'm going to exit the live stream and I'll try to answer the questions on the you know uh, on the YouTube or Facebook. I'll take one last question from Apurva. Kind versus Minikube, which one will you prefer for local Kubernetes? Today, if you ask me, I definitely prefer Kind over Minikube. Minikube seems a little too heavy to me, like very bloated. It almost kills my machine almost every time I try to use it. Kind is much leaner. I can create like one node cluster, two node clusters, or three node cluster based on my requirement. And the best part is with Kind, becoming so lightweight, GitHub Actions also now supports Kind, so I can actually use it in my CI workflow and as well as on my local machine. So there is like consistency in that sense. I'm sure there are some limitations to Kind as well, but let's not talk about right now. It doesn't hamper my any of my use cases definitely.
Thank you guys for attending the live stream, and I thank Vishal for giving the presentation on behalf of Pune developers community. Thanks everyone.
Cool. Thank you. Bye.